2009 Nissan Rogue. Air conditioning stuck on. Well, the blower motor is stuck on. It's stuck in the high position, even with the car, with the blower motor turned off. Let's go take a look. Let's turn the key on. Oops. Alright. Now have a look there and see what position that blower motor is set to. Set to off. Don't matter where you put it. Blower motor is on all the time. I'm sure you can hear it. Alright, so I've got the wiring diagram printed out, and I'm going to start at the fan motor. It's not too difficult to get to, but it does require me to pull the glove box out. So let's start with that. Alright, so change of plans. Instead of playing around with what's behind the glove box, absolutely nothing, because the diagram said right side of dash. Well, you can see it from the right side of the dash, but it's actually accessible and removable from the left side of the dash. Anyway, let's turn this light down. That's too much. There we go. That's better. Anyway, we are going to attack at the control head. So here is the wiring diagram. And right there where the arrow is pointing, that is the blower motor. It gets its power from right there. And we know it's getting power, so that's not an issue. So let's follow the ground. Let's follow the ground. And the ground wire goes to the fan control amplifier, right there where the other arrow is pointing to. The red wire is the ground wire, the ground side control for that. And the blue wire is the control for the amplifier, which comes from the AC amplifier behind center of dashboard. Let's get that focus. So that comes from here, the blue wire, fan gate, F-A-N-G-A-T-E, is the control for the fan control amplifier, which is down here. Come on, focus. Alright, let's zoom out some, and then we'll just zoom in while I edit it. Alright, so that's it right there. Fan control amplifier, which is basically the control head. Blue wire controls the fan control amplifier at the bottom. And we should see a duty cycle on there. I'm assuming we should see a duty cycle. So let's see what we have on that blue wire at the back of the control head, which is right here. In this panel, you're gonna have to stick a tool on the side, preferably something plastic, and pry it out. I already did that. I didn't want to look like an idiot if I couldn't get it out on camera. Anyway, this is how it's attached, just clips. Let's get some focus on there. Those clips right there, all around each corner. Just pop them back, comes out. And now we're going to find our blue wire. So let me see if I can get the camera set up somewhere so that you guys can see what's going on. So this is the blue wire right here. At least I think it is. Let's get our oscilloscope ready. Yeah, you guys can see. All right, good. So let me go back, probe it into the black, which is a ground wire. I don't know if I made contact. Yeah, I'm in there. Okay. Now let's find my blue wire. I may need power since that's going to be ground pulse, but I should still be able to see something there. That's my blue wire right there. It's the only blue wire, and it's next to the red on the diagram anyway. So let's see what we got when we turn the key on. That is 500 milliseconds. The blower resistor is no good, man. You've got no power, no activity on that signal wire, but yet the fan is still on. What does that tell you? It tells you that the blower resistor is no good. It's shorted. It's stuck on. Change the blower resistor. Okay? Good luck. Bye-bye. Alright, we've got nothing there, so let's turn it on. Still got nothing. Alright, since we have no activity on our blue control wire for the blower resistor slash blower amplifier, we're going to cut that blue wire or eliminate it from the circuit. If we can get it out of the connector, that'd be great. We couldn't get it out of the connector, so we decided to cut the blue wire and see if our blower motor stays on. If the blower motor stays on with that blue wire cut, then we know for certain that the blower resistor is no good, because the blower resistor is probably shorted internally and causing the circuit to complete, which leaves the blower motor stuck in the on position. So that's what we're going to do next, and let's see what happens. Alright, so I'm gonna cut it right there. That should give me enough room. Cut it right here. Check it out. My fan is still on. That means my control head is okay. And that fan is being turned on by something else. Alright, so I suspect that since the module is seeing the fan on all the time, that is not sending duty cycle signal to the fan controller, which is this little thing right here. Oh, but that focus on that. Alright, since we know that this module, the fan controller, fan speed controller, is bad, for sure, because you can unplug the control wire and it still stays on. No control wire there, it still stays on, the fan runs all the time. So this is definitely bad. So we're going to swap this out and see if we get our signal back. Alright, so this fan controller, which is probably blown out, resides back there, way back in that corner over there. And to get access to it, you have to take this panel off. This panel comes off really easy. Really, it comes off just that easy. Just yank it from the bottom and pull it out. And it's up in the corner. You're not going to be able to see it from right here. It's in the corner back there. But you can feel the plug. See if I can get my hand in a better spot. It's in the corner back there. You can unplug it from right here, and you're gonna have to sneak in there. I may take this gas pedal assembly out. You can kind of see it from over here, right up there in that corner back there. Oh, I just half focused and I lost it. Back there, right there. That's it. That's the guy back there. I'll put an arrow pointing to it when I edit the video. So we're going to swap that out. Alright? Let me take that out, and I don't think I need to take the gas pedal out, but we'll be back. Alright. As you can see, the car is in the on position. The blower switch is in the off position, and the blower is off. And it's working properly, too. I don't know if you can hear it, but you can hear it. It's on now, and we have it set to the high position. So let's do some testing and see what the hell we got going on. Trying to figure out why we don't have a signal there. We didn't have a signal there before. So let me pull this control head out and hook up the scope and see what we got going on here. Alright, so we're going to hook up our oscilloscope. Alright, so we're going to hook it up here. Black wire to ground, because I think that's a power feed circuit. Okay, I think we are connected to ground, and we are going to connect it to the blue wire, which is our signal wire. Okay. Turn the key on. Let's turn you to the scope. All right, we've got nothing right now, so let's turn the key. 2 volts per division, 5 millisecond time base. Key is in the on position. Blower is off. That is low. See, before when we were in low, we didn't have, what voltage is that? That's 2.5 volts, which is what the spec is in the flow chart, which is what we should have there. So let's see how this system works. 2.4. Oh, wait. So the voltage is increasing. I'm going higher and higher on the dial, and the voltage is increasing. And that's full voltage. Let's change the scale from 1 volt to 2 volts per division. All right, so that's 2 volts per division. Well, it was on 1 volt per division before, so let's go back. That's 0, that's off. That's low. How many volts is that? 2.4 volts. 2.6 max. Low, a little higher, a little higher, a little higher still. And is that 10 volts? Yeah, 9.12 volts. I do have the charger hooked up, all right? Alright, so we got 2.5 to 10 volts range. So I guess it's just a 2.5, 2.4 to 3.5 volt signal until you get to high. Let's put that on the 1 volt scale and then be done with this testing here. Let's go down here. This thing is lagging a little bit. And I'm gonna change my sample rate back to 10 million. Oh, wrong button. Okay. All right, so that is off. That's low. 1, 2. Oh, 1, 2. 2.4 volts. 1 click, 2 clicks, 3 click, 4 click, 5 click, 6 click, 7 click, 8. There's a gradual increase in voltage, so I guess that's what we gotta look for when you're diagnosing this system. It's not duty cycle control like I originally thought. I did another video about the 3-wire blower motor on another Nissan, and I thought this system would probably be the same, except for that the thing would be offset, but it's not the same, it's different. That's full blast right there. That's off, that's low. Alright, so I guess that's how you diagnose it. You look for that signal. And if it's stuck on, then you simply pull the power supply from the, pull a signal wire from the resistor and see if the fan stays on. If it stays on, then obviously the resistor is bad, but I'm not sure why we would lose the signal from... I'm not sure why we would lose the signal going to the blower resistor or the blower motor controller, blower fan speed controller. Anyway, maybe because the module is seeing that the fan is on, because it does have another wire. We'll get to that a little later. It has another wire that goes in. I think this red wire is a feedback wire, and it lets the module know that the fan is running or not. And I guess if it sees that fan is running while the switch is in the off position, it just doesn't send a signal to that to protect itself for some reason or whatever. Maybe there's some type of logic there that I don't know. Anyway, it works. The resistor fixed it, and we'll get into more detail later. Thank you for watching.